Okay, this is 6-3. Notice it does say on it 3 days. It does take about 3 days to go through it without getting overwhelmed. We are starting some of the pre-cal stuff. Okay, this is laying the groundwork for the stuff that's going to come up in the semester. So make sure you understand this. Okay, go to this slide right here. Angles, rotations, and degree measure. In Trig, we often think of an angle as a rotation. You are used to hearing there's no such thing as a negative angle. Now there is. Surprise! There actually is. What's the difference between a positive angle and a negative angle? It has nothing to do with negative value. It's the direction that it rotated. So, geometry was, here's an angle, there's an angle, here's an angle. Those were static. Pre-cal is, imagine an alligator mouth opening up in a given context. That's angle. That's the type of angle I need you to think of. Okay, no longer this static, here's a V, there's a V, there's a V. This is saying it was closed and it's opening up. Because if it's positive, it opens in one direction. If it's negative, it's opening in the other direction. And that's really important, okay? A couple of vocab words to start learning. If you want to highlight them, you can. It's up to you. One of the first vocab words is vertex. You should already know this. The vertex of an angle is like the elbow. The vertex of our angles will always line up on the origin of the coordinate plane. And then, which brings me to the next vocab word, initial side. I'm going to face the same way y'all are facing. So the initial side will always line up on the positive x-axis. That one never moves. That one's permanent. Think of it as the bottom of the alligator's mouth. That does not move. It's the terminal side that moves. You with me? As I'm showing you with this really high-tech illustration. The terminal side is the one that is actually rotating to move to the given angle value, and then it will land, terminate, wherever the value tells it, like 45 degrees or 180 degrees. You with me? If an angle is positive, it's going to rotate the way that you're used to seeing, like this. If it's negative, it's going to rotate in the opposite direction from the initial side this way. Now, how are you going to remember this? Let's box this in. You got positive, then you got negative. Two ways to remember this. What type of numbers are above the x-axis? Positive. What type of numbers are below it? Negative. It's going to rotate as a positive. If it's positive, it's going to begin rotating up or counterclockwise. With me? Analog clock. It's going to start rotating counterclockwise. If it's negative, it's going to hit the negative numbers first. Think of negative x. And it's going to rotate clockwise. So it's a little backwards, but a positive angle rotates, watch how I abbreviate this, counterclockwise. A negative angle rotates clockwise. This one is describing counterclockwise, and this one is describing clockwise. Another thing that you need to remember that's going to come up a lot is being able to identify the quadrants. How many quadrants are there? There's 4. You need to know where they are. This is really important. The 4 quadrants start in the top right, and they count counterclockwise. how are you going to remember that the quadrants count, start from top right and count counterclockwise? Watch this. This is stupid, but it works. Draw a little coordinate plane over here. This is the coordinate plane, right? What does coordinate start with? C. How do you write a C? Stay with me, Brody. How do you write a C? You start up here and you go this way, correct? The way you write a C is the same way you label the coordinate plane with your quadrant numbers. With me, that's how you remember. So this is 1, 2, 3, 4. So maybe make a note. Think coordinate plane. The way you write a C is how you label the quadrants on the coordinate plane. How are you going to remember that a positive angle is counterclockwise and a negative angle is clockwise? What direction did you rotate with when you drew the C to label the quadrants? What direction is this? Counterclockwise. So that's how you remember that going counterclockwise, I used positive numbers to label the coordinate plane. So positive angles run counterclockwise. So I'm trying to show you techniques for remembering this, because if you get this stuff confused, your whole answer is wrong. You're going the other direction, you know what I mean? So let's make sure you understand this. I'll say it again. The way you draw C is how you label the coordinate plane with your quadrant numbers. The numbers are positive, so you remember that positive angles go counterclockwise. If you can remember that one, then you know negative goes the other way, clockwise. Like, just memorize one, because then the other is what's left over. Okay? So let's look down here at these examples. It's kind of hard to tell because your paper is printed in black and white, so if you need a colored pen or something. All right. Notice these four up here. You've got this one here. Then you've got this one here. This one here. And then this one here. Those are the four angles in those pictures. Look at those four compared to the next four. What do you notice is different? There's something different about them. These down here, they look like they're, I don't know, they look more complicated. What do you notice about these four that I've highlighted in purple?
They're simple.
They're very simple. Do you notice they overlap the axes? Like this was the x-axis positive. This was the entire x-axis. This was positive x, positive y. This was positive x, negative y. There's a vocab word to describe an angle whose initial and terminal sides land on the axes. You're going to hear this a lot. It's called quadrantal. I didn't make it up. A quadrantal angle means an angle that encloses at least one quadrant in it, like the whole quadrant, sometimes two, sometimes three. So if you look at this one right here, notice that they do give you the arrow to say the rotation. Like if you look at this, you probably think the angle didn't even get drawn all the way. It did. There was a rotation there. It opened up from the initial side. It opened up all the way and then landed back on the initial side. But the arrow here is telling you the rotation was a full 360. This is 180. Now we've got two angles here to start to practice recognizing the positive rotation or the negative rotation. A positive 90 would be starting and then opening up to 90, or I could have started and rotated to 70 and I land in the same spot. You with me? Or you can completely flip that. I could start here and rotate negative 90, or I can go positive 270, and I still land in the same spot. These are quadrantal angles, which brings us to the next vocab word you're going to hear a lot, coterminal angles. Coterminal angles means an angle formed by two different angle measures, but when you think of the rotation, they're the same angle. They look like the same angle. For instance, here's the angle here. Brody, stay with me. This is opening up positive 135. I'm going to try to underline that. Or it's opening up negative 225.
Positive 130.
No, it's both. It's both. Like, they're coterminal. They mean the same thing. If you were to open up a positive 135 angle, and then on the same coordinate plane open up a negative 225 angle, they land in the same spot. Just like over here, negative 90 lands in the same spot as positive 270. So those two angle measures are called coterminal. Because if I graph the angle on the coordinate plane, I look like I've only plotted one when there's actually two there. Right here, negative 30 is going to be the same angle as positive 330. Wrap your mind around that, like imagine it, negative 30 or positive 330. Can you go more than 360? Yes, you can. This is a full rotation and then some, right? So we are beyond 360 now. So it's a full 360 and then another 60 more, which lands it at 420. You can even go past that. This is a full 360 and then an additional, what is that, 180? That would be 240. This is 110, negative 110. So this angle right here and then this angle here have two totally different measures, but when I plot them on the coordinate plane, they land in the same spot. They have the same initial side, the same terminal side.
So the difference, like both of the coterminal and quadrantal angles, they can both be told by positive and negative, but that's the difference that the quadrantal ones are on the axis and the other ones aren't both on the axis?
Yes. Coterminal angles don't have to be on the axes, but they can be, like 90 and negative 270. They are coterminal quadrantal angles. Yeah. None of these down here are quadrantal. Go to the next slide. All right, find two positive angles and two negative angles that are coterminal with 51 and negative 7. Remember, coterminal means angles with the same, you don't have to write this, it's on the other slide, but I'm just reminding you, with the same terminal side. All right, so we are finding with 51 degrees, two positive, two negative. If I want to find a positive angle that lands in the same spot as 51, what do you think I need to do with 51? Imagine where 51 lands. Let's go back here. Let's work with 90. All right, we have 90 degrees here, right? If I want to get another angle that lands in that exact same spot, what do I need to do? Yes, that works. Or can go subtract or addition. So you can either do a full rotation, 360 added on, and then you'd have another angle, or you can do a full rotation subtracting and you land in the same spot. So if you notice, the difference between coterminal angles is always a full rotation, which is what number? You just said it, 360. So if I need 2 positive, I would take 51 and do plus 360 the one time, right? And then I can take that and add another 360 to get another angle. What's 51 plus 360? 411? So 411 degrees. Then you would take 411 and add another 360 to get a second positive coterminal angle. Now they also want 2 negatives with it, so what do I do to get a negative? Take off the full rotation. What do you get? Negative 309, negative 309, and then take negative 309 and do another rotation off. What do you get? Negative 669. So if I was to go to a coordinate plane and draw 51 degrees, 411 degrees, 771 degrees, negative 309 degrees, negative 669 degrees, I'd have all those angles on the same coordinate plane, and it would only show what? One angle, because they would all land in the same spot. The difference was just how many times it rotated. Okay? They want you to do the same thing, but with negative 7. So you're adding a rotation, writing it, adding a rotation, writing it. Then you're going back to negative 7 and you're taking off a rotation, subtracting a rotation, writing it, and then subtracting. Tell me if you've got these numbers.
Yes.
There's one more thing I want to show you, because I know some people will be working on their homework tonight, and it would help them to be able to answer more questions. I'll show you real quick. Right here on this slide, we're going to take actual notes on it tomorrow, but I know some of you, how some of you are. Complementary, supplementary, you should remember that from geometry. Complementary means they add up to equal 90. Right here, notice this adds to 90. Supplementary means they add to equal 180. If I say, tell me the complement of 20, you have to know that complement adds to 90. So the complement of 20 would be 70. Because 90 minus 20 is 70. The supplement of 20 would be 160, because 180 minus 20 is 160. So that should help you with a couple of problems. We'll take actual notes on it.